Okay, section 5.9, we're over at the left-hand side of our notes. We're on page 335 in the textbook. Let's look at number 14. 14, the instructions are write a polynomial that goes through the set of points. And when it says it like that, it means that the line should go through. It should hit each of those dots. So -1, -15. Number 14, 1, -7. And finally, 6, -22. Okay, so find a line that goes through each of these 3 points. Let me clear out my calculator. Second plus 712. And why don't you do the same and try to find a line that goes through those. Go ahead and pause. All right, let's see how you did. So stat, edit, -1, 1, and 6. -15, -7, and -22. So we have 3 points, so I need a degree 2 or a quadratic to fit these points exactly. So stat calc, let's see, a quadratic should fit these exactly. And it's just asking for the model. So here is the model. So the model is y equals ax squared, but a is -1. So -1x squared, -x squared, plus bx plus 4x minus 10. This fits that data exactly. It didn't ask me to graph it, but you know, maybe I should just for fun. Let's see, vars, y vars. Okay, put that under y1. So you can see there's my function, and it puts the -1 there. It doesn't need that though. We know that that's silly. And let's go to plot 1 and turn that on. Zoom stat. I'm kind of going through this quick, but just to see, yes, there we go, through 1, 2, it goes through the points perfectly. Okay, so number 14, let's see, find a polynomial function. This is your answer though. The function is your answer. That's what they were looking for number 14. The next two, we're going to try a couple together because they relate to each other. We're going to look at let's see. Whoops, I put my calculator. 16 and 20. I set my calculator down on top of my notes. We're going to try 16 and 20 together. 16 says, for each set of data, compare 2 models and determine which one best fits the data. Okay, so it's asking you to just come up with a couple of different models and see which one's better. So for 16, here's your data. 1965, 80, 95, 80, 95, and 2005. And 630, 1300, 1950, and 2650. Okay, so those will be your X's and your Y's. They have other labels there, and we'll talk about context in a minute. But that is what we're going to start with. And let's go ahead and, again, get rid of the 19. Just use those numbers there. Remember to use 105 for this last value because you're adding an extra century on there. So use 105 for that last value, and that way it will all kind of look the same. Let's see. So go ahead and try that. Okay, we're back. Let's see how you did, and then we'll try number 20. Let me clear my calculator. Beautimus. Okay, stat edit. 1965, 1980, whoops, 65. I'm all verklempt. 95 and 105. Okay, 630. 1300, 1950, 2650. And these are dollar values. These are not years, so I'll just leave those as they are. Okay, it's asking us to find a couple of different regressions. So let's see, I have 4 points. I can do up to a cubic. So I could do a cubic, a quadratic, or a linear. I'm going to do them all. I just feel the need to do that. So put the linear regression under y1. Okay, let's see, stat calc. Put the quadratic regression somewhere else. How about under y2? Beautiful. Look at that. That's a mess. Can you imagine writing that down? It's terrible. And finally, let's put the cubic regression under y3. Ugh, what a mess. So that's all in there right now. And if I go to y equals, turn on plot 1, so it'll plot my points, zoom stat, and we can look. Okay, there's the linear regression. That's kind of close. There's the quadratic regression. And there is the cubic regression. The cubic is kind of go through all 3 points. Let me zoom out, which is kind of what we did before, to see how it's acting. Okay, so the linear, that looks pretty good. The quadratic, that's all right too. And there's the cubic. Well, which one do you think is best? You know, I think you can go for the linear or the quadratic there. I'm kind of torn emotionally between them. Let's see. The book says. What does it say? It says both. Oh well. I'm going to kind of go ahead and try the linear one. I'm going to say the linear one's the best. So if you disagree with me, if you say the quadratic is a little bit better, and I guess it depends on who's going to get elected president, what the federal spending is going to look like, yeah, never mind. I changed my mind. I'm going to like the quadratic a little bit better because it's kind of, you can see that over time, you know, 1900 should be kind of low, but the linear regression just goes beneath the x-axis. They can't spend negative money. So maybe I'll go with the quadratic. I think that's a little bit better. So quadratic is what I'll like. That was a quiz question to need to be a little more clear cut. And let me go ahead and write that down. Y equals, now just for my notes here, I put that under y2. So y2 equals, you don't really need that, 0.371x squared minus 13.7x minus 28.5. Okay, so I think that pretty well models that data. I like it. Okay, now I also said to try number 20. So using that, we're going to look at number 20. So go ahead and try that. I'll go ahead and pause. Whoops, I guess I should write it down first. 20. Estimate total U.S. federal spending for 1990 and 2010. Estimate for 1990 and 2010. Estimate for 1990 and 2010. So it's asking us a couple. 1990 is in between here. That'd be interpolation. I think I say that word wrong. And 2010, that's beyond my data. So that's extrapolation. So it's asking us to, using this model, figure out what it would be around 1990 and 2010. Okay, hopefully I didn't pause already. Go ahead and pause. Okay, we're back. And all I need to do here is I've chosen the quadratic regression. All I need to do is tell the calculator, still use y2 for me and plug in, well, 1990, that'd be 90. And for y2, plug in 110. Okay, and that will give me my two values. That's all I need to do. I need the calculator to crunch those for me. I could just put those values in for x here, and it would tell me the same thing, except maybe a little bit of round-off error, right? Because it didn't write out all those decimals. But it's already in the calculator. Have it do the work for you. Isn't that insane? Your math teacher is telling you, use your calculator. Use it. We need to get stuff done. We don't have time to sit there and have you type in 20,000 different things. Okay, so y2 at 90 is 1741. And does that make sense? Sure, look at your data. Okay, 1741, 1990 is in here, so 1741 is in between those, so that makes sense. So 1741, and all of my y coordinates are rounded off there, so I think that's pretty safe. Maybe I could have even written, they all end in 0, they're all multiples of 10, so maybe I could have even written 1740, but I'll write some whole number there. And for y2, or sorry, for the second one at 2010, let's see, second entry to just bring that back. Second and enter. That's a nice little trick. Whoops. I didn't mean to do that. There we go. And punch that in. And so at 2010, it thinks the federal spending will be about that value. And I guess we could check that. That's in the past for us, right? So 2950. 295. I guess I should write 2951. It's 0.7. So 2950. 0.51. So those are your estimates using the model we picked. If we picked a linear model, they'd be a little different. If we picked the cubic model, they'd be a little different, but I think this model looks pretty good. I mean, if you just looked at the points, you know, when we were zoomed in under zoom stat, they all looked pretty good. Zooming out a little bit, I think the quadratic. Anywho, we already talked about that. Do your 3 questions.